Yes. Which of the following is not correct? This is the graph related question, whereas graphs are recorded with respect to density versus temperature, density versus 1 by temperature, and density versus pressure. If we establish the relations between densities versus temperatures, density versus 1 by temperatures, and density versus pressures, all these are getting derivatives of PV is equal to N into R into T. Whereas here this density will becomes equal to mass upon volume, whereas number of moles will becomes equal to weight upon gram molecular weight into 1 by V into R into T, whereas this weight upon volume is known as density. So if I write, that is pressure is equal to density by gram molecular weight into R into T. These of all graphical interrelations are with respect to one particular gas. So therefore gram molecular weight remains constant, R value remains constant, temperature also remains constant. So therefore here density, one particular relation is density versus temperature. Suppose density versus temperature, if we take the graph, remaining all, if I feel, remains constant, that is d into t will becomes equal to what? Some constant k. Whereas density versus 1 by t is a part-time part of this relation. Let us go for density versus pressure. If temperature remains constant, then density versus pressure relation is present like this. Density is equal to some k into d. These are the two things. Suppose if I go for density versus temperature relation, density into temperature remains constant. It is similar to that of PV is equal to nRT relation. So therefore density one side followed by temperature one side. If density increases, temperature should decrease, whereas temperature increases implies density should decrease. Such of relation is maintained. Suppose if I take the graph, that is density versus 1 by t, if I rewrite this equation, density is equal to k by t, that is y equal to mx form. So therefore it is passing through the origin. So therefore density versus 1 by t if I take, so density versus 1 by t, density versus t, if I take density versus 1 by t, y equal to mx, this 1 by t is on x-axis, slope will becomes equal to some positive constant passing through the origin, whereas pressure versus density interrelates as p is equal to k into d, whereas here d versus p graph if I take, that is also y is equal to mx graph, pressure versus density or density versus pressure passing through the origin because there is no intercept. Such of relations like d versus t hyperbolic relation, d versus 1 by t straight line relation, p versus d straight line relations are correct. But in that graphs, there is a graph except these three, along with the three options of these, another one relation is also present and is of d versus t is a straight line. This was a graph. This graph is not valid graph because when temperature increases, volume increases. When volume increases, density should decrease. But here both are increasing. It is not correct. Hence this particular graph is incorrect in relation with the density versus temperature.